Part 1, 1993 to 2006. Accepting the need to tear everything down and rebuild to survive. Nvidia was like a team building a race car. They chose to make square wheels because they believed it was the better approach. But right at that moment, the entire industry agreed to use triangles, the direction Microsoft pushed with DirectX. Nvidia built a product in a language the market didn't want to use. And when Microsoft drove DirectX toward triangles, Nvidia was left standing on the wrong foot. Now comes the life or death part. A tech company lives on cash. If you only have enough money for a few more months, and the product you're building is heading in the wrong direction, then pushing forward is just burning through what's left. GDK die a little slower. Some sources say Nvidia had only about 6 to 9 mid-K runway at that point. Jensen Huang did was incredibly difficult, but absolutely right. He didn't ask, how much effort have we already put in? He asked, can this thing still save the company? In a crisis, the most dangerous thing isn't losing past effort. It's clinging to past mistakes. The engineering team had done a massive amount of work. But if the foundation is wrong, building faster only accelerates your demise. So Jensen forced them GDK you abandon nearly everything and pivot to what the market actually needed. Instead of trying GDK win on every front, Nvidia decided GDK play by one clear rule. We will win on performance. They focused on making their chip faster, more powerful, and aligned with industry standards. This led to the Riva 128, the chip that pulled them out of disaster. Then came the most audacious move, software emulation. Normally, making a new chip takes a very long time because you have to design it, build a physical prototype, test it, fix it, then manufacture it. Nvidia didn't have time for that. They used software to emulate the chip before building it. It was painfully slow, roughly one frame every 30 seconds. But it eliminated many rounds of waiting for physical prototypes, cutting the cycle from nearly 2 years down GDK, right? Sounds paradoxical, right? Think of it like this. Walking is slower than a motorcycle. But if the road is jammed solid for 10 hours, cutting through the alley on foot gets you there sooner. Now, the next breakthrough. Before programmable shaders, a GPU was like a baking machine with only 5 preset GDK. It was fast, but it could only do what the manufacturer allowed. Nvidia saw something critical. If the GPU stays a fixed piece of hardware, sooner or later it will be commoditized. A giant like Intel could bundle basic graphics into its chipsets and strangle the standalone graphics card market. So Nvidia transformed the GPU from a machine that runs preset commands into a machine you can write new commands for. That is the meaning of programmable shaders. When the GeForce 3 launched in 2001, it supported programmable vertex and pixel shaders, and this was the turning point that brought programmability to consumer GPUs. Old GPU equals a keyboard that can only play 10 presets GDKU, equals a keyboard where the musician can compose and play anything. Once the GPU became programmable, it was no longer just hardware that draws pictures. It became a specialized processor. And people realized, if it can run small programs on massive amounts of data in parallel, it can do many other kinds of computation too. This is exactly the path that led to GPU compute, CUDA, and eventually AI. Part 2, 2006 to 2022. Betting the entire company on CUDA. Before CUDA, the GPU was like a massive crew of workers who only knew how to do one job, draw graphics. They were fast and strong, but if you asked them to do physics simulations, matrix operations, or model training, it was nearly impossible. CUDA, introduced in November 2006, was the decision to transform that crew from specialists who do one thing into an army that can take on all kinds of tasks, as long as you write clear instructions. The core idea was not just making GPUs more powerful, it was transforming the GPU from a graphics component into a computing platform. Nvidia wasn't selling a piece of hardware anymore. They were building an entire ecosystem, a programming language, a compiler, libraries, drivers, development tools, and a developer community. This was an enormous gamble. Nvidia spent a fortune building a highway when almost nobody was driving on it yet. Wall Street wanted to see customers, revenue, and short-term profit. Jensen Huang did the opposite. Build the infrastructure first, wait for demand to appear. Then in 2012, AlexNet exploded onto the scene. The world suddenly realized deep learning actually works. and the AlexNet paper states it was trained on two Nvidia GTX 580 GPUs. Before that, AI was like a seed with potential, but nobody had the machinery to grow it at scale. Nvidia's GPUs plus CUDA were a factory already built and sitting ready. When the AI harvest season arrived, only Nvidia had the factory ready to run. GPU before CUDA, a factory full of robots that only know one move. GPU after CUDA, the same factory, but now you can program the robots to do many different jobs. Deep learning arrives, and suddenly the whole world needs exactly that kind of factory. Nvidia wins big because they had quietly finished building it years earlier. Part 3, 2022 to 2023. From selling chips to selling entire AI systems. Imagine, Nvidia used to be a company that makes engines, very good engines, but they sold them for others to put into cars. The problem is, if you only sell engines, someone else decides the car, the electrical system, the chassis, and the biggest profits may lie in the whole car, not just the engine. Nvidia didn't want to be the engine supplier forever. They wanted to sell the entire machine. As Jensen Huang put it, the data center has become the new unit of computing, not a single chip, not an individual server, but the entire data center cluster operating as one giant machine. They separated their chip architectures, Hopper for data center AI with tensor cores and transformer engine, Ada Lovelace for GeForce gaming with ray tracing and neural graphics. The right chip for the right battlefield. They built Grace, their first data center CPU, because if you only have GPUs, it's like having excellent chefs but no head chef to coordinate the kitchen. They acquired Mellanox in 2020 for networking technology because you can have 1,000 skilled workers, but if the roads between workshops are too narrow, the whole system bottlenecks. With GPUs, CPUs, high-speed interconnects, and software all under one roof, Nvidia no longer sells individual components. They sell entire AI factories. That's the logic behind DGX SuperPod and DGX Cloud. Nvidia used to sell engines. Now they sell the entire manufacturing plant. And when customers buy the complete solution, switching costs go way up because you'd have to replace the entire stack, not just one chip. The result? Nvidia achieved a GAAP gross margin of 75% in Q4 of fiscal year 2026. The deepest lesson across all three eras is this. In business and technology, winning isn't about stubbornly continuing what you've invested the most in. Winning is being clear-headed enough to abandon the wrong thing at the right time, then pouring everything into what the world truly needs.